Welcome to the deep dive. Today, we're really getting into something significant, this idea of the era of experience in AI.
Yeah, it's a concept from David Silver and Richard Sutton, and it
Mm.
it really suggests a major shift is coming.
Exactly. And we're diving deep into their paper today. We're assuming you, listening, you've got a good handle on the AI basics already. This isn't AI 101.
No, definitely not. We're aiming to really unpack what they mean by this era of experience.
Right. What defines it? What are the implications, especially for the kind of advanced AI systems we're seeing develop? That's our mission for this session.
Okay, so where should we start? Maybe with why the current approach, the one based on human data, might be hitting a wall.
Good idea. I mean, we've seen incredible things, haven't we? LLMs writing poetry, solving physics problems, medical diagnoses.
Absolutely stunning progress. Summarizing legal docs, coding assistance, it's all driven by training on these huge amounts of human-generated text and data.
But the paper makes a strong case, maybe too strong for some, that just imitating humans and learning from our static data,
Hmm.
well, it has limits.
Especially, they argue, in areas where we need truly new insights. Think high-level math, fundamental science, maybe even complex coding paradigms.
Yeah, the argument is that the best quality human data, the stuff reflecting peak human intellect in those really tricky domains, we're running through it
The
fast.
finite resource, right? Think about all the established mathematical proofs or the documented scientific breakthroughs. There's a lot, but it's not infinite.
Exactly. And true breakthroughs, by definition, are things we don't know yet. They're outside our current documented knowledge.
So you can't really expect an AI to leap significantly beyond human understanding if it's only learning from what humans have already written down.
It's like trying to design a skyscraper using only blueprints or bungalows. You need something more.
Which sets the stage perfectly for their main idea, the era of experience.
Okay, let's get into that. The core concept, as I understand it, is shifting the source of the data.
Right. It's not primarily about scraping more websites or digitizing more books. It's about AI agents generating their own data.
How? By interacting with the world.
Exactly. Learning continuously from their own actions, observations, experiences within an environment. And the claim is this experiential data will eventually dwarf human data.
Wow. Okay, so instead of just reading the textbook, the AI is actually doing the experiments.
That's a good analogy. Learning through trial and error, exploration, direct feedback from whatever domain they're operating in.
The paper uses alpha proof as an early example, right? The one that won a medal in the IMO.
Yeah, that's a key piece of evidence they point to. It learned initially from human proofs, sure, but only a relatively small set.
But then it generated vastly more.
Hundreds of millions of its own proof attempts interacting with that formal proving system is that massive self-generated experience.
To let it find new solutions, stuff humans hadn't.
Precisely. It went beyond its initial training data through its own experience. And there's other work, too, like DeepSeek AI in informal math using RL.
Where the agents develop strategies just based on rewards, not explicit human teaching.
Right. Autonomous development of problem-solving skills. It really points towards this shift.
So this changes the game. Okay, the paper then lays out some key characteristics defining this new era. First up is streams of experience.
Yeah, this contrasts with a lot of current AI, where interactions are often short, like a single prompt response or maybe an episode in a game.
Right, very contained.
The idea here is agents operating over long, continuous streams of interaction. Think more like how we or any biological system learn over a whole lifetime.
So it's about persistence and learning over time, accumulating knowledge.
Exactly. It enables things like long-term goals. Imagine a health and wellness agent tracking you for years, constantly adapting.
Or an education agent that follows the student right through their schooling, personalizing things continuously.
Or science agents running long-term experiments. It's about taking actions now for potentially very distant payoffs, a fundamental shift from short-term episodic tasks.
Okay, that makes sense. Then the next characteristic is richly grounded actions and observations. This sounds like moving beyond text.
Definitely. While language models are amazing, this is about agents interacting with the world more directly.
Through sensors, robots?
Could be physical, yeah, motor control, sensors, or digital interacting with APIs, user interfaces, controlling remote equipment. The point is acting in an environment, not just processing text about it.
And getting richer feedback because of that direct interaction.
Much richer, more nuanced data. And, crucially, the agent can actively explore. It can poke the world, see what happens.
In ways maybe a human wouldn't even think to try.
Potentially, yes. It's about moving from passive learning, from human communication, to active agent-driven discovery through interaction.
Which connects nicely to the third point, rewards grounded in the environment.
Ah, yes, this is a big one. So much current AI, especially things like aligning LLMs, relies heavily on human feedback, humans rating responses.
RLHF, instruction tuning, all that.
Right. But the paper points out a limitation. Your AI is kind of capped by the understanding and biases of the human raters.
Makes sense. If the human doesn't recognize a brilliant but unconventional answer, they might rate it down.
Exactly. Grounded rewards are different. They come from the environment itself. Objective signals.
Like what? What are some examples?
Well, for that health agent, it could be actual physiological metrics, blood pressure, glucose levels. For the education agent, maybe real exam results.
For science agent, measured carbon dioxide levels or the yield of a chemical reaction or material properties.
Precisely. Real-world consequences.
Hmm.
Even user satisfaction ultimately is a grounded signal reflecting their experience.
And the advantage is it bypasses human judgment limitations.
It bypasses human prejudgment, potentially. It allows the agent to discover strategies that achieve the real goal, even if those strategies look weird or non-intuitive to us initially. The reward signal comes directly from success in the world.
That feels powerful. Okay, and the final characteristic they list, planning and reasoning about experience.
Right. So we see reasoning in LLMs now, often looking like it emerges from predicting text, mimicking human thought patterns expressed in language.
Which is impressive.
Totally. But the authors speculate. Maybe human language isn't the only or even the most efficient way to represent and reason about the world for all tasks.
So agents learning from experience might develop different ways of thinking, non-human-like computation.
Potentially.
Right.
Maybe symbolic reasoning, maybe something using distributed representations, maybe complex differentiable models.
Yeah.
We don't know yet. But the key is that this reasoning would be grounded.
Grounded how?
Grounded in the data collected from its own interactions, not just grounded in the patterns of human text.
Ah, so it avoids inheriting all our built-in human biases and maybe flawed assumptions that are baked into our language and data.
That's the idea.
Yeah.
By learning directly from the consequences of actions in the real world, the reasoning is tied to reality. This is where world models come in.
Right, the agent builds an internal model of how the world works based on its experience.
Yeah, predicting if I do X, then Y will probably happen. This allows for planning, for thinking ahead based on its learned understanding of cause and effect in its environment. It makes the intelligence much more robust and adaptable.
Okay, this paints a really clear picture of the era of experience, but why now? RL isn't new. We've had successes in games and simulations for a while. The era of simulation, they call it.
True, and the paper acknowledges that. The era of human data kind of surged ahead because training on massive web text gave broad capabilities relatively quickly. It seemed like a faster path for many real-world tasks.
More generalizable, maybe?
Initially, perhaps. But as we discussed, it has that potential ceiling. The real catalyst now, they argue, is seeing clear proof that experiential learning can lead to discovering genuinely new knowledge.
Like AlphaZero and Go, beating the best humans with strategies learned entirely through self-play.
Exactly. That self-discovery aspect is key. Combine that with increasingly capable agents that can interact meaningfully with the real world or complex digital worlds.
And powerful RL algorithms that can actually handle these complex, open-ended problems.
And you have the conditions for this shift to the era of experience becoming, well, not just possible, but maybe imminent.
And this shift also means revisiting some classic RL ideas. Things may be pushed aside a bit during the LLM boom.
Definitely. Things like value functions, estimating the long-term value of states or actions. Exploration techniques, how does an agent explore effectively and safely in the real world? World models, like we mentioned, temporal abstraction reasoning across different timescales.
These all become super critical when you're talking about agents learning continuously from rich, real-world interaction streams.
Right. The paper suggests we'll likely see new developments here. New ways to define rewards just from observation, better ways to estimate value from long, messy, incomplete data streams, principal exploration, much more sophisticated world models.
It feels like a whole research agenda opening up.
It really does.
So let's talk consequences. If this era takes hold, what does it mean? The potential seems huge.
Immense. Truly personalized long-term assistance, like we touched on. Imagine AI genuinely helping manage chronic health conditions over decades.
Or accelerating science dramatically. Agents designing experiments, running them, analyzing results. potentially much faster than humans can.
Discovering new materials, new drugs, maybe even new physical principles. The ability to learn continuously from direct experience is a powerful engine.
But there are downsides, or at least major challenges, right? The paper mentions them.
Absolutely. Significant challenges. Concerns about job displacement are obviously there as AI tackles more complex cognitive tasks.
And trust becomes even more critical. If you have an agent pursuing long-term goals autonomously,
Yeah.
you need to be very sure those goals are aligned with yours.
A huge alignment challenge. And interpretability might get harder if the reasoning becomes less human-like, as we discussed. How do you understand why it's doing what it's doing?
Those are serious points,
Right.
but the paper also hints at potential safety benefits from this approach, which seems counterintuitive at first.
It does, but think about it. Agents learning continuously from experience are inherently more adaptable to changes in the environment. They aren't brittle, like systems trained only on static data,
Okay, I see that. Less likely to fail catastrophically if something unexpected happens.
potentially. And also, if a reward function turns out to be slightly wrong or misaligned, you might be able to detect that through real-world feedback and correct it incrementally over time.
Instead of discovering the misalignment only when something big goes wrong,
Maybe. It offers a different kind of feedback loop. And there's another point they make.
which is,
The inherent speed limit. Self-improvement isn't instantaneous when it relies on real-world interaction.
right, you can't speed up plant growth or chemical reactions indefinitely just because the AI is smart. Physics still applies.
Exactly. Interaction takes time, running experiments, observing consequences. There's a natural break on how fast certain kinds of progress can happen, which might be a sort of passive safety feature.
Interesting. Okay, so wrapping up, the key takeaway really is this fundamental shift. Moving away from AI progress being primarily driven by digesting human knowledge.
Towards progress driven by autonomous agents learning directly from interaction with their environment,
Yeah.
generating their own experience, their own data.
And this promises capabilities that could go far beyond simply mimicking or even extending human abilities, potentially unlocking truly novel solutions and discoveries.
But it comes with massive technical challenges in RL, in safety, in alignment, interpretability, and significant societal considerations too,
It's definitely not a simple upgrade. It's a whole new paradigm.
for sure.
So here's something to leave you, our listener, chewing on, particularly given your technical background. If these experiential agents do develop forms of reasoning that aren't just echoes of human thought, if they compute and plan in ways fundamentally different from us, how do we even begin to design interpretability tools that can give us real insight? How do you make sense of an intelligence that doesn't think like you? That's a huge question for this next era.
A profound one.
Definitely something to keep exploring. Thanks for joining us for this deep dive.